now the head of data at Palmetto, which is a company on a mission to increase access to clean energy. So here we see the environment again. How does data science contribute to the adoption of clean energy solutions at Palmetto? And what are some of the data challenges you face in the industry?
Yes, I am working at Palmetto, which is focused on the solar industry today. And I think, like many tech companies in the energy space, there's a very big vision for the role data can play in terms of optimizing the grid and making our energy systems more efficient. But I'll zoom in on the solar problems first. So, the process of going solar as a residential consumer is extremely fragmented. In all likelihood, if you, as a homeowner, are thinking about going solar, somebody knocked on your door and you opened the door, which are already bizarre events. And from there, you said, sure, come on in, take a look at my roof. I'll give you access to my utility bill. I'll tell you some information that you can get financing with. And throughout all of that process, you're giving all of this information up front. And then eventually the salesperson has to go through and determine with your utility whether you're going to be able to sell energy back to the grid. That's really important for making the finances work out. They're running a credit check or reaching out to a financier to ensure that you can get a loan. They're validating whatever design that they've created for the solar panels for your roof with a design firm that confirms that your roof is up to scratch and can support solar panels, determining if you need a re-roof, if you need to take any trees down. So all of the steps along the way include a large number of different players. And so part of making this industry more widespread or more impactful is an efficient marketplace process. And so I've worked at marketplace businesses before Palmetto, and it's been really interesting to see how those concepts translate, looking to find out, use data to understand timelines between different steps of a process and optimize the balance of different players in the marketplace, in this case, many-sided. You have different types of supply interacting with this demand of the homeowner. And so that's a big part of data. There are supply chain problems. We're working with different types of hardware, solar panels, inverters, batteries. There are new types of hardware coming out from the US, which are preferred for a lot of reasons, financial and otherwise. And we might want to strike that. It's a little bit political. But constantly, there's supply chain problems for solar hardware, panels, inverters, and batteries, and a lot of new development in that space. And you want to work with what customers want. And then we're also looking at how we can automate some of those friction points more directly. So one piece of automation Palmetto's building is a solar design tool. So I mentioned having a physical design of the solar panels that go on your roof and using AI technology to understand what the contours of your roof are, how you can optimally place solar panels to generate maximum kilowatt hours given where you are on the earth, the shape of your roof, and the needs of your home, which we can do using building data to understand your energy footprint. We're also doing a lot on the financing side. So right now with rising interest rates and inflation, Palmetto saw viability of loans decreasing. And so we launched our own power purchase agreement and hardware leases, which make it possible for you to put solar panels on your roof and not have a big loan against them. So you're paying either a fixed monthly fee or just a fee for the energy you use. That means for us, we have pretty traditional financial data science work to do. So we're underwriting loans and we are predicting the risk against those loans. We also need to understand more than your credit, the climate risk of your home. And we're taking, again, into account the viability of the hardware and whether this solar system will produce the energy that we've promised you. And that gets into one of my favorite sets of problems we're working on today, which is this predictive maintenance space. So in the past, we helped install solar systems. And then we said, congrats, you have a solar system. Now we own panels on a lot of roofs. And we need to maintain those because it's an asset on our books as well as a service we're providing a customer. And so looking at the production curves relative to those designs we've built, and looking for both anomalies as well as comparing these forecasts and being able to preemptively determine when maintenance is needed, as well as understanding the different error codes coming out of this diverse set of hardware to give our technicians a recommendation of the next best action they can take. It's really expensive to roll a truck to a home. So things that we can solve remotely are ideal. And once you've gone solar, you not only want your panels to keep working, but you have this source of free electricity, which really changes your decision making with regards to what you're doing at your home, the appliances you put in it. So suddenly gas stoves and fireplaces and water heaters aren't looking as good. So Palmetto is working on providing guidance to customers on how to further reduce bills and increasing energy independence by recommending whether you should buy a certain device or make a certain upgrade. And so a really fun data problem here that takes me back to some of the data sets I worked with 10 years ago, early in my career, is using 15-minute interval data about the energy you're producing as well as what you're consuming, which we get from solar panel inverters, as well as we have the option to get from utilities directly, is to understand your energy footprint of your home and use those really granular readings of kilowatt hour consumption to understand what devices might be running. And so bigger devices are obviously easier to pick out. That was something even 10 years ago in the early dawn of machine learning we were pulling out in my time at O-Power, things like hot tubs, EVs, but even air conditioning. And if you have room by room readings, you can really start to pull out more insights there and make really useful recommendations to people. And where I start to get really excited beyond solar is when you have a large access to a large number of these distributed energy resources, that becomes really valuable to the grid at large. So you can start selling energy back as a unit instead of household by household. You can use this as an option during demand events to work with a utility and say, instead of turning on a coal-fired plant, which you're really hoping to take offline permanently, you now have this network of homes that can sell you energy they're producing. And so part of that is getting consumers to reduce their usage during these demand events and having that trusting consumer relationship. And then part of it is the grid optimization work. And there are some really cool startups in this space right now approaching it with all sorts of different devices, appliances. And I think solar is a really good entry point.
There was a parallel that came to mind for me there when you're talking about these energy flows from consumers out into the grid when there's a demand event. It sounds a lot like when I order an Uber and I get surge pricing. And so there's like this incentive in like this automated system that is disincentivizing me from using that service or requiring me to spend more. It sounds like a super similar kind of problem.
Yeah, I'm not sure how much you look at your utility bills or have clicked around your website, but you probably have options for different rates that you could sign up for. Just standard rates are typically like you'll pay the same amount for a kilowatt hour of electricity at any hour of the day. But you can also sign up for rates that will let you pay a lot more if you use energy during a time when your utility forecasts high demand and a lot less in the off hours. And that
Mm.
incentivizes people to use the timer settings on their dishwasher and laundry, for instance, run them at 10 a.m., get home, you still have to turn your lights on, but maybe don't run those other high power consuming appliances. And that's a version of surge pricing, basically. And this idea of using distributed energy resources to further optimize those times is, I guess you would think of as kind of, so surge pricing is the Uber rider financial impact, control of demand. This distributed energy resource idea is the supply side, where you're saying, like the way Uber offers incentives to drivers to drive at certain times of day. This is offering consumers the option to be a part of the grid.